So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.
Welcome to this week's Energy Show. Now this week, we're talking about carbon capture and sequestration, more commonly and easily known as CCS. Now this technology is being hyped as a solution to our continued CO2 emissions and as a way to take the existing CO2 out of the atmosphere. So it's got a lot of potential. We can stop the emissions with this, and we can draw down or reduce the CO2 that's already in our area that's really causing global warming. So CCS is a pretty straightforward industrial process that works best at the source of the emissions. Now, the biggest place where we're getting these CO2 emissions are kind of obviously coal and natural gas plants around the world for generating electricity. Now, secondly, the biggest source are industrial processes such as cement making and steel manufacturing. Also, obviously, there's a lot of emissions from transportation, but that's much more diffuse, so it's not a single source. I mean, you have one of these little plants on the tailpipe of every car, not that practical. And there's better solutions. So when I look at CCS from a thermodynamic, an economic, and a technological maturity standpoint, CCS is fundamentally flawed on all three dimensions. First, CCS requires a lot of additional energy to remove the CO2 from power plant exhausts and air. It just takes energy to do that. We'll talk more about that later. Second, this additional energy is expensive. So the whole process of CCS is pretty non-economic. It just costs a lot of money. That way, the electricity, nobody wants to pay for it. And you also got to realize from a technological maturity standpoint, this technology has been around for 100 years. For 100 years, we've known how to take carbon dioxide out of the waste stream. And there's still no CCS plants that are even close to being ready to scale up. So as a result, I'm convinced that pursuing CCS will actually increase our CO2 emissions. It's going to make things worse. If we didn't even have this technology, we would be on a faster, better, cheaper course to solve our global warming problem. All right, but why are we here? Why are you even talking about this TLA called CCS? Well, the reason is that fossil fuel companies have a big problem. And these are huge companies. They employ lots and lots of people. They're enormously profitable. They've been around for 100 years. The problem that fossil fuel companies have is their product, burning oil and gas, is unacceptably polluting. And they've been denying global warming forever. And now they're kind of grudgingly accepting it because the science is widely accepted. And society, governments are moving aggressively towards reducing emissions. Finance companies, banks, stockholders are saying, hey, I don't want to invest in companies that are really going to be polluting. And there's this weird kind of concept among the oil and gas companies that somehow they're going to be green companies. I think BP and Exxon said they're going to find a way to eliminate their emissions. It's like, how are you going to do that? You're burning oil and gas, and nobody will be buying that expensive oil and gas. It's almost impossible. But they're talking about it because it's what's required. And they're trying to find a way to keep using fossil fuels, even if there's this figment, imaginary CCS concept in the future that's going to solve it. All right. So in a nutshell, CCS is a solution for us to keep using fossil fuels. It's an idea. And if it someday possibly work, we can keep burning fossil fuels until there's no more fossil fuels. But in the meantime, while scientists and engineers are trying to perfect and scale up CCS, and we'll talk about those plants in a minute, the fossil fuel companies are going to keep polluting. The mantra, their message is, we're working on it. We've got all these grants. The government's supporting us. We're going to solve this problem in 5 years, 10 years, 20 years, 50 years. In the future, somehow we're going to find a way to solve this problem. So basically, they're kicking the can of practical CCS farther down the road, and we're really no closer to it. Particularly, the road is kind of taken a U-turn going towards renewables that really are working now. So basically, I'm not opposed to doing research and pilot projects. Personally, I think it's a waste of money, but if fossil fuel companies, if the government wants to invest in this kind of long shot, maybe there'll be a CCS technology breakthrough. And also, we're still going to need liquid fuels for the foreseeable future, and we'll talk about why in a minute. So wouldn't it be nice if we could continue to use liquid fuels and if we could pull CO2 directly from the air? I mean, that's kind of the goal. That's why the government's investing in this research. So here's the thing. So let's kind of look at pulling that CO2 directly from the air. We're talking about a way to draw down the carbon dioxide that's already in the air. CO2 in the air, the percentage of CO2 in the air is 0.04%. It's negligible. Air is 78% nitrogen, 21% oxygen. So extracting this really, really diffuse CO2 from the air takes a lot of work. I mean, you get enormous vacuums that are just sucking in air and pulling out that tiny, tiny fraction of a percentage of CO2 from the air, and then finding a way to capture it and then bind it together so it never gets away. So sounds like a good idea. But one estimate is kind of interesting, practical. One estimate is if the technology really does scale up based on the energy that's required to vacuum in the air, capture the CO2, and then put that CO2 in a place where it's not going to go away, is going to take 25% of the entire world's energy production. So I'm kind of skeptical. But I talked about the future where we're still going to need liquid fuels. Liquid fuels are really useful. And here's why. They have a very high energy density, about 43 times more energy per unit mass in liquid fuels. And the term is specific energy. So the specific energy of jet fuel is 43 megajoules per kilogram. And those units are kind of kooky, but let's look at the energy density of the very best batteries we have. It's about 1 megajoule per kilogram. So if you take a kilogram of jet fuel and a kilogram of a fully charged battery, you get 43 times more energy out of that kilogram of jet fuel. That's why it's such a good fuel. Heck, when the jet is halfway to its destination, it uses half the fuel, probably less. You want to have some reserve. But when it uses half the fuel, the jet has lost all that fuel weight and it runs even more efficiently, whereas you're still dragging those batteries around. So it's going to take a long time for battery-specific energy. It's improving at like 5% or 6% a year to really get high enough where the numbers start working out. Even after taking into account that the additional weight of the battery, it's much bigger, 43 times bigger, is mitigated by less weight for the engines. So you know how in an electric vehicle, the engine to power that electric vehicle is tiny. It's the size of a suitcase, whereas you got a whole trunk full of what you need for an internal combustion or a jet engine. So we could get there, and there's some trials of electric little planes. Very cool. It's got a battery. It's got an electric motor. Flies for a little while. Yeah, and we're talking about something that could fly humans around instead of drones, playing around with those drones. But eventually, I'm confident that we'll get to the point where we can fly with an electric motor and it's battery powered. It's going to take a long time before that's really practical for hauling lots of people through the air and equipment. All right. So where else do we use fossil fuels? Well, in addition to these liquid fuels that we need for certain transportation applications, we use fossil fuels for industrial process heat applications. Here's two of them that are very common that use an enormous amount of energy. Making cement represents 8% of the world's CO2 emissions. And we talked about the cement process in a previous show, but it's just 8% of the emissions just come into making cement, and we use that cement for concrete. I kind of talked to a friend about this, and we're going to be using a heck of a lot more concrete because we're going to have to be building more seawalls and dikes around the civilization that we have in our world that's near the ocean, because the oceans are rising. And instead of moving people inland, which we're going to do anyway, you're going to have to be building these seawalls and barriers to keep the water from coming in. So cement is going to continue to use 8% of the world's CO2 unless we find a way to cut back on that. And there are some ways to cut back on a little bit. Now, secondly, making steel. First you make iron, then you make steel, but the whole process represents another 8% of CO2 emissions. And it's possible to capture some of the CO2 emissions from those processes in some ways. You can capture it from, the cement kiln is emitting a lot of CO2, and when you're making steel, you put coal in and you get CO2 coming off that. So there's ways to capture it, and that makes a lot of sense. So besides air transportation and these industrial processes, almost everything else can be done with batteries charged with renewable energy. Trucking, heating, obviously lighting, almost everything else. And so the improvements in battery technology and the reductions in cost for renewable energy, solar, wind, are coming down really fast. So we really have to kind of focus on just air transportation and industrial processes, and we don't need to burn fossil fuels for anything else. All right. So how do we use CCS? Why is it holding back some of these transportation industrial processes? And why is it not scaling up for most of the usage, which is power plants? Well, CCS, carbon capture and sequestration. First, we need to capture the CO2 out of the waste gas stream. When you have a natural gas plant, coal plants generally in the U.S., they're going away. They'll go away in the rest of the world. But even in natural gas plants, you can capture the CO2 that comes off the waste stream. Simply, when you're burning a hydrocarbon like methane, you get carbon dioxide and you get water and you get energy. So this technology to capture carbon has been around for a long time. It's simple chemistry to extract the CO2 from this pretty high concentration of gas that's coming off this, mostly CO2 and just water. So it's this process called carbon scrubbing. You might have heard about it. It's a reversible chemical reaction, and basically use this chemical called amine. And amine, it's hard to pronounce. It's basically a nitrogen, it's like ammonia. And this amine absorbs the CO2, so you capture it. And then you can take that CO2 that's in the amine, you take the amine, you heat it up again later, and then the CO2 comes off and you can use the amine again. So it's a reversible process. And you're absorbing the CO2, it's like a sponge, and then you squeeze the sponge by heating it, CO2 comes off, and then you have to capture that. So after the CO2 is captured, we need to do what we call sequester the CO2. Now, just storing the CO2 in a tank, capturing it, doesn't really help because that CO2 is going to eventually leak back in the atmosphere. I see people saying, hey, we're going to use this CO2 to make fizzy soda, or we're going to use it for something else that's temporary. That's not going to work. It's just going to bubble out, and then you really haven't accomplished the reduction in CO2. We need to permanently sequester that CO2 so that it never leaks back into the air. Now, one popular common process is to inject that CO2 into oil and gas wells, because there's these holes in the ground. We just put the CO2 way underground and then cork it and hope it never comes out. I'm not a fan of this because, first of all, we don't need more oil and gas wells. And the oil and gas industry says, well, we can improve our production of oil and gas by squirting CO2 into the well, and then it's going to force more oil and gas up to the surface. We don't want more oil and gas. And then I'm also, kind of skeptical. I just think what's going to happen is we don't really do a good job of taking care of our oil and gas wells. The old oil and gas wells leak like crazy. Companies go out of business. They don't care. There's this pipe in the ground with a cork on top. I'm worried. I'm not worried. I'm sure this is going to happen. The oil wells are going to gradually burp the CO2 back into the air. So we went through this whole process. Oil and gas companies got a pat on the back. We saved the CO2. We injected it in the ground. It's gone. Don't worry. Thank us. Our stock goes up. But 20 years later, it's out again. So I don't like that idea. A better process is to bind the CO2 back into a mineral. So we can make calcium carbonate, which is limestone. We can make that from CO2 and calcium. Great idea. We kind of put it back into this limestone. The problem is it's a good idea, but it uses a lot of energy to take calcium and make calcium carbonate again. And that's kind of a ubiquitous problem with all the CCS concepts. It uses a lot of energy. So let's take a look at the most successful CCS projects so far. As of 2019, there were 10 large-scale CCS projects in the U.S. All of them pull CO2 from power plants or factory combustion emissions. So they're putting them next to a power plant and they're generating the electricity, and then they're able to get that CO2 and they say, we're going to sequester that CO2. Don't worry, trust us. So for example, there's a plant called Petra Nova, big plant in Texas. It burns coal, and then they use the captured CO2 to extract more oil and gas from oil wells that are in the area. So you're taking the CO2 that's in the coal and you're putting it into the ground. It may not stay there. And then you're getting more oil and gas out of the ground that's going to actually create more CO2 in the atmosphere. I'm not a big fan. I have a big problem with this concept. You're just burning more coal and you're going to end up with more oil and gas. So there's a lot of other projects like this that are on the drawing board. There's lots of funding. The government's behind this. The new Biden administration, they're putting money into it. I think that's okay. Maybe there'll be a breakthrough, but I wouldn't count on it. None of these projects are working cost effectively at scale. You get these little plants, the concept works. Concepts work for 100 years. But when you look at the cost of running that plant, and the cost of the energy that the plant is generating, it's not cost effective anymore. So let's look at a more recent project that was just canceled. This was a big project. It was called the Kemper CCS plant in Mississippi. Is another design of a CCS system that was adjacent to a coal power plant. And the idea was, hey, we're going to find a way to burn this coal cleanly, put billions of dollars into it. And they canceled the project a few years ago. So, I look at it, it's like really, really simple. And people just kind of ignore this reality because they want to keep burning fossil fuels. Obviously, the fossil fuel companies want to do that. There's no such thing as cheap and clean coal. You can get expensive clean coal. You can get cheap, dirty coal, but you can't get cheap and clean coal. So here's the reality. Renewables and battery storage, it's growing really fast, and it's been growing quickly for the last 20 years. And the reason is there's this concept called the learning curve. When you get to a technology that's economic and people start adopting it, like wind and solar and battery storage. Yes, it's kind of expensive to get those batteries if you can get them, but still they're working and they're economic. And there's not a lot of subsidies that are required to do that, if any. So we're very far down the learning curve for wind and solar and storage. The deployments, the installations are growing really, really fast. And so we're making progress there. And I hate to say it, but these things are cost effective even without incentives. With incentives, we're going to get deployments going even faster. Now, CCS, it's been around for 100 years. It's a simple chemical process. It's not scaled because it's not economic. There's better alternatives. So basically, the learning curve of CCS is stuck because of the high costs for CCS and because of more practical, cheaper, easily installed alternatives. It boils down to chemistry. We get energy when we break the carbon-hydrogen bonds in hydrocarbons, get CO2 and water. It takes a lot of energy to put that CO2 genie back in the bottle again. That's why it doesn't make sense. So if we spend the same amount of money for carbon capture and clean energy generation, so we look at doing the CCS technology, one option, or clean energy generation on the other, we're going to end up with 10 times more CO2 from burning the fossil fuels that after this carbon capture technology compared to solar and wind. So even after you clean it up, dollar for dollar, you get 10 times more emissions from burning fossil fuels than solar and wind. So basically, in a nutshell, you can't please the oil and gas companies that their product is going to be somehow clean and safe again at the same time as you're reducing emissions. The numbers don't work, and you can't argue with that. Now, what's the consensus of world governments? I mean, finally now the U.S. is part of those world governments. So what do the governments say? Well, there's this thing called the Intergovernmental Panel on Climate Change, the IPCC. I did a show on it. And here's what they say. The words are English, but it doesn't make sense. Here's the sentence. In model pathways with no or limited overshoot of 1.5 degrees C, the global net anthropogenic CO2 emissions decline by about 45% from 2010 levels by 2030, reaching net zero around 2050. That's the sentence. All right, so this is what it means in plain English. By 2030, 9 years from now, 9 years from now, the world needs to cut its carbon dioxide pollution by 45%, and by mid-century reach net zero emissions. That's meaning that any CO2 after 2050, mid-century, is going to have to be zero or drawn down. So basically in 9 years, we need to cut our carbon emissions by 45%. The only way to do that is by eliminating the use of fossil fuels or cutting it back incredibly drastically. CCS is not going to help us do that because the concept doesn't scale. It's not even working in a pilot plant. How are we going to ramp up to cut those emissions by 45% in 9 years? And in 29 years, we have to have zero emissions. Otherwise, the temperature is going to go over by 1.5 degrees C. And that's going to be bad. So there's no freaking way that we can keep burning fossil fuels and hope that CCS will scale in 9 years and be cost effective. So what do you do instead? Much better to scale existing technologies that work and are already cost effective. Because if it's cost effective, they scale. Now, put a little bit of money into it, they scale even faster. It's really a bad idea to continue to burn fossil fuels in the hopes that CCS will someday work cost effectively at scale, especially since it doesn't work even close to cost effectively on a pilot plant basis. There are other technologies that are winning, and there are other technologies that people want to buy. Electric vehicles, solar, onshore wind, offshore wind, lots and lots of other ways to do it. Basically, since CCS doesn't economically scale and no one really wants the CO2, except oil and gas companies who are going to use it to drill for more oil, it doesn't work. So CCS, stick a fork in it. We're better off without it. Cross it off. All right, so we're going to have to do some of these pilot plants and do that for a while. We're going to waste a bunch of government money. And in 10 more years, we're going to say, well, we tried, but it didn't work. Meanwhile, we've got all these other technologies that are working effectively. Okay, that's all the time we have on this week's Energy Show. Thanks to all of our listeners for tuning in. And if you missed any of today's show, you can go to our website at cinnamon.energy and listen to the podcasts.
So, you want to save the world with clean energy? Make money doing it? Confused about the economic and technical realities of residential and commercial solar, batteries, heat pumps, EVs? Want the real-world scoop on new energy technologies, not manufacturer hype? Then tune in to the Weekly Energy Show, hosted by Barry Cinnamon. Insights from Barry's 40-plus years in the solar and energy industry will help you understand the future ways we'll generate and consume energy. And now, here's Barry.